Hello friends, you are watching ERUDIRE Plus, the professional CAD/CAM solution provider. Let's get started.
Hello friends, today we'll show mechanism analysis of a crusher using PTC Creo7. Model is actually consisting of different links. We'll start from the assembly itself. So let's start from assembly. New, and we're starting from assembly. Okay. It will be millimeter Newton second, assembly design absolute. Okay, so to start from assembly, let us import these links one by one. It is already there in the desktop with the folder PTC Creo models. Inside this folder named PTC Creo models, it is consisting of different links. First, we will take the bottom part, that is base plate. It will be having a default location, green check. Next one, you have to import another link from the assembly. Let us take plate with hole. Now for assembly, let us take this one towards the pin junction. It is clearly understood that this one will be having pin joint. So from user defined, we can change it to pin joint, and this pin will be connected with this hole. One constraint is met, but to satisfy another one, let us select this face should be matching with this face. So both the constraints are satisfied. It is okay. You can rotate this one a little bit. Okay, so first link is assembled, green check. Next one, we will import the same thing again, and that to be attached at this location. Okay, so from assemble, we can import that same part, plate with hole, open, that to be taken at this location. And again it will be having that pin connection. So from user defined, we can select pin, and this hole should be matching with this hole, and again the surfaces, this face should be matching with this face. Okay, so both the constraints are met. It is okay. We can rotate this a little bit. So assembled here 3 different parts. Okay, you can check. Let us import that the central part from the assembly. You can take it. The central plate should be inserted. Okay, for assembly we can drag it towards this location. And again we know that this will be having pin connection. So from user defined, we can select pin, and this face should be matching with this cylindrical face. One constraint is met. So again this surface should be matching with the top surface of this pin. Done. So it is complete. Now we can rotate a little bit. This part should be matching with some other part. Okay, so the 4 different parts have been assembled together. Green check. Next one, we have to import that top plate that should be attached at this location. So assembly, you can import that top plate, and we can drag it at this location. Again it will be having pin connection, so select pin from the user defined. This space should be matching with this cylindrical face, and the surface also, this surface should be matching with the top surface of this pin. So it is done. I can rotate this one a little bit, right? Okay, fine. So green check. So let us import that pivot part. Open. Let us drag it towards this top part, and it is clearly visible that it should be having a pin joint in between these two. So from user defined, we can select pin. This cylindrical face should be meeting with this hole. One constraint is met, so this surface should be meeting with top surface of this pin. Both the constraints are met, but the thing is, this pivot should be having some specific distance from the bottom surface and from this plane also. So with a new placement, we can provide another relation for this pivot. Placement, new set, and it was pin joint, so we have to replace this one with general connection, and we can provide a distance of the bottom face of this pivot. Should be having some specific distance with respect to the bottom plate, right? So you can select the bottom plate also, and let us provide a distance of this one as 760 millimeter. 760 millimeter, and again we can provide a distance of the side face of this pivot with this plane with a specific distance. Let us provide this plane and the side of this pivot should be having specific distance. Let us put the distance to be 450 millimeter. Green check. It is done. Now the last part to be assembled again. You can have a fit view of these links. Okay. Now the last one, that means this link should be connected with this crusher. You can drag it a little bit down for this crusher part. You can drag it again. Okay, fine. Now we have to import that crusher part. Let us close it and import that crusher part. Select that crusher part. Open. We can drag this crusher part towards this link. Slider connection. So from user defined, we can select slider, and we know that for slider it should be connected with one edge and one plane, right? So we can rotate this one a little bit and select some surfaces. Slider connection, this edge you can select one edge, right? So we can drag this one a little bit closer to this base plate. You can rotate this one a little bit and select that edge or line. Should be meeting with this line. Done. And again one surface is required. This surface should be meeting with the bottom plane of this crusher. Selected. Green check. We can slide a little bit. By the same time, we should have a new connection for this crusher with this down link. Okay, so with a new set, we can have a new relation, and it will be having pin joint. So select a pin joint. This face should be meeting with this face, and again the top surface of this pin should be meeting with this face. All the constraints are satisfied. Green check. Our assembly is ready, right? Now for better understanding of this model, we can provide a specific colors to different links. From the appearance, we can provide. Let us provide some dark color for this base part. Okay, and again different colors can be provided for different parts. Let us select this link with yellow color, and we can provide yellow color to this pivot also. Let us select yellow color for this pivot. Okay, done. Now we can put some other colors like red color for this different link, and for this crusher we can provide blue color. We can check, done. Now we can have a feed view of this model, and we can remove these different lines and axes. Okay, right, this is our model. Now we can drag and see whether it is working or not. Yes, it is working perfectly. Now we can start our mechanism analysis. For this mechanism analysis, you have to start with applications, mechanism, and we have to provide servo motors. At this location, you have to provide a servo motor, right? With respect to this pivot part, this top part will be rotating and the crusher will be moving to and fro. So we can select the servo motors. At this location, you have to provide a servo motor, and we can select that location or preference of position of the servo motor. Profile details, we have to provide angular velocity, and the velocity should be 60 degrees per second. And let us see the properties. Motor 1 is attached. Now we can go for mechanism analysis. Initially you can go for kinematic analysis, and from there we will find out velocity, acceleration at different locations. Start time 0 and end time 10, and the frame rate we are considering as 10. Let us run this one. It is done. Okay, now we can have a playback for this mechanism. Analysis definition 1. Let us play this. You can see how it is moving. Let us take a feed view of this one. We can increase the speed also a little bit. This is the mechanism, and from this mechanism we can have acceleration, velocity, etc. And from dynamic analysis we can have something else like connection, reactions, etc. Let us close this one and go for analysis of these things. Okay, we can have velocity, acceleration, etc. from measures, and we have already undergone this analysis definition 1 that we selected. And what do we want to measure? We want to measure velocity, acceleration, etc. Right? So that to be started from here. Create a new measure. We want to have velocity, acceleration, etc. for any specific location or any specific position we can have, right? So we are finding velocity. Suppose you want to find velocity at this location, right? Or for this crusher. Let us find velocity for this crusher at this point. Selected. Apply. Okay, so this is already obtained. You can see velocity is equal to 291.438. This is velocity, and we can have a plot of this one with respect to time. Velocity is 291.43 degrees per second, and we can have a plot of these things, right? This is the plot. Along x-axis we are having time, and along y-axis we are having velocity. So that is providing velocity of that crusher part, right? So its maximum velocity is 451 something, 450. It is near about, we can say it is 450 something, right? And it is coming to 0. Again, it is going up. For 10 seconds, actually, we have conducted this simulation. Next one, we want to see acceleration of that location, that crusher part. So we can change this one. We can edit these measures with respect to, instead of velocity, we can have acceleration also, right? Acceleration, apply. Okay, that is showing acceleration is 243.342. That one we can have a graph. So this is the graph for this crusher part. The same way you can have the velocity acceleration for different locations, right? You can see here initially acceleration was actually more than 100, approximately 4900 millimeter per second square acceleration at this moment, at this location. Okay, so what we found, this was actually our acceleration for this crusher part. Similarly, we can have acceleration velocity for any specific location. Let us see acceleration of this part, right? Let us see that one. With the analysis definition 1, we have to select any specific part. We can go for a new measure. Let us select the velocity of this location, right? This one. Apply. Okay. It is showing velocity of this location is equal to 60. And you can have a plot of this one. It is constant velocity. This is having 60 degrees per second, which is having constant velocity at this location, right? Let us see for acceleration for this location. Instead of this one, we can have acceleration. So let us edit this part. Instead of velocity, we want to have acceleration for this location. Apply. Okay. It is 0. As it is having constant velocity, so definitely it will be having 0 acceleration. It is defined clearly. Now next one, we can go for this dynamic analysis, right? And from mechanism analysis, we can go for dynamic analysis. With analysis definition 2, and instead of kinematic 1, we can go for dynamic analysis. In that case, we have to include external load also. So we are having motors, and external load, it will be gravity. Let us run this one. Okay. Now let us see the playback of this one. We can have playback of the definition 2, second one. Let us run this. Let us close this part. Now want to have dynamic analysis of this mechanism. So we'll start from measures. It is second one. This is analysis definition 2, and we want to find out different velocity and acceleration at different locations. Let us find a new measures, and we want to have velocity of any specific location. Let us have velocity at this location. Apply. Okay. And it is showing velocity at this location equal to 60 degrees per second, as we did before, exactly same thing. Let us have a graph of this. It's constant velocity, so definitely it will be having 0 acceleration. And we can have some other things like, instead of velocity, we want to have connection reaction of any specific location. Suppose here. Apply. Okay. So it is available here. Now you can see in the form of graph. So connection reaction we can have, that is connecting force in terms of Newton. Its maximum value is equal to 5 into 10 to the 5 newtons, and minimum value is less than 5, that is near about 2 newtons, right? The same way we can have different things like trace curve, that at any location how the path will be traversing, that one we can find out from trace curve. We want to have a tracing curve of any specific location, and that can be obtained from here, trace curve. And with respect to any analysis, suppose we are selecting the second analysis definition 2, and we have to select any specific point, right? Let us select that point and preview. It is showing this is the path traversed by this location. Okay, this is the path given in this violet color. This is the tracing curve of this crusher. Similarly, you can have tracing curve for any other locations also. Let us have it. Let's close this part, and we want to have tracing curve for this location. Okay, so analysis, trace curve, and to select analysis definition 2, and to select that location, right? Suppose you want to have for this location, any location you can find out. Suppose you want to have trace curve for this location, this point. Okay, let's preview this. So this is the trace curve for this location, right? Let's close it. So this is all about our today's video regarding mechanism analysis of a crusher part. This is the crusher. This will be moving to and fro with respect to some central position, right? If you like this video, please subscribe and share. And if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again. Bye.